Okay, so let's have a look at the last one in chapter 3. This is 3.5 symmetry. Okay, we've got quite a bit of new vocabulary, or vocabulary you may have known. All right, so symmetry, there's a lot in nature that's symmetric, including yourself, but sometimes it's just line of symmetry, or sometimes it's rotational symmetry. So we're going to have a look at all, both of them, and we'll see how we go. But first of all, we're going to do line symmetry. So this is where you can put a line through it, and if it reflects onto it, then that is definitely the line of symmetry. Some of them have got one, some of them have got multiple, some obviously have got none at all. Okay, so if we look at example 1, number A, the crab, as you can see, they've got a line of symmetry in there. Then you've got the starfish. Okay, well, if you go through one of the legs all the way through, you're going to get 5 there. And then obviously the oyster is none at all. Okay, so use a ruler if that helps. And if you can see the same on one side as you can see on the other, it's got line symmetry or line of symmetry. Okay, so let's have a look at what we've got. Let's start with number 1. First and foremost, you've got to write yes or no, and if so, then draw all the lines of symmetry. Well, number 1 is a rhombus, so it's definitely got to be yes. Okay, but what lines have we got? Well, we've got the corners, and again, you can use a ruler, I can't. So we've got all the corners, but don't forget the sides as well. Okay, so we can do that, all right, and state their number. So this guy is going to be 4. Okay, so now we're looking at rotational symmetry. Now, don't forget we were going to rotate 360 degrees, and every time you see that shape in its normal state, then that's the order of 1. So every time you rotate it round, let's just say it's a regular pentagon, then all the way around you would see it 5 times, so that would be order of 5, okay? And then that would be 72 degrees, because 360 divided by 5 will give you 72 degrees. Okay, so this is a regular hexagon, so this is a 6-sided figure. So first and foremost, we know it's the order of 6, and if we do 360 divided by the 6, it will be every 60 degrees it will look identical. Okay, so let's have a look at question number 4. First and foremost, write yes or no. Okay, well this is a pentagon, but it's not a regular, so that one's going to be no. It's got line symmetry, but it hasn't got rotational symmetry. Okay, let's skip on to number 6. Number 6 definitely is a yes. Okay, and don't forget we're going to go 360 degrees, and every time we see it in its same shape, that will be the order, and then we divide that order into 360. Okay, well, as you can imagine, every 90 degrees, so every 90 degrees, it will look identical to the position it's in now. So that's got to be order of 4. Okay, and then that will tell you how many degrees it is. So 360 divided by the 4 will give you the 90 that I said right at the beginning. Okay, so now we're looking at reflections and rotations this time in example 3. Well, first and foremost, we've got a rectangle. Has it got line symmetry and or rotational? Well, we know that it's got line symmetry. Okay, and the best thing to do when it's on a coordinate graph like that is actually to find out where the center of it is first. So I would actually do step 2 first. I'd do the diagonals first, and that will give you the center. And then all you've got to do then is go half distance on each of the lengths to find your line symmetry, and also to tell me what the line is. So the first one is x equals a half, or 0.5, and the second part is y equals 1. And then when you do the diagonals, there's your point, which is obviously the 0.5, and the 1 from your x and y is your center of symmetry. So let's have a look at number 8. Okay, well, we know number 8 hasn't got any line symmetry, but it is rotational. Okay, and then if we draw the diagonals a bit more accurately than I'm doing, but that's where the center is going to be. Okay, and if I look at the coordinates of that, that's going to be 1, 1. So if you draw them accurately, you will be able to get that center without doing too much calculation.